Hi, I'm Myron Ferguson. I own a drywall contracting company here in Galway, New York. Throughout the years that I've been in business, I've had a sense that people are either afraid of working with drywall or overconfident about working with drywall. A lot of people have asked me, why do you want to do such miserable work? It's dusty and dirty and heavy. There must be something else you could be doing for a living, maybe something easier. Other people think that's all you need to do is buy some 4x8 sheets, nail them up quickly, apply a few coats of joint compound, and you're done. A quick, easy job. But the truth is, working with drywall is not miserable work. But it's not particularly easy until you've learned to work with it correctly. I like the physical part of the work. It keeps me moving all day. And since the work progresses quickly, I can really see what I've accomplished, and so can my clients. But drywalling requires particular patience and skill and attention to the details of the process in order to get the job to come out well. A few months ago, my crew and I started the drywall work in this, my brother's new home. Come on back with me and I'll show you what I mean. Here we are driving up to the house to measure and estimate for the drywall job. And I'm already thinking about things like accessibility to the site, the condition of the driveway, location of power lines, and anything that might interfere with delivery of the materials we'll need. The house is conventionally framed, about 3,000 square feet of floor plan, and it's been under construction for about 6 weeks at this point. I start with a quick walk through the house to figure out where I'm going to start measuring and find out how ready things are for my crew. I want to see if the electrical wiring is roughed in, if the plumbing and heating are roughed in. Is the framing complete? Is insulation done? Has the building inspector okayed everything so far? This water cutoff and any other large plumbing projections have to be removed before we start, and hanging electrical sockets have to be tucked up out of the way. Here's the master bedroom with its high, steeply pitched ceiling and gable end walls. Each inside corner has to have a good nailing surface for the drywall. This is good. This is good. But here's a place where there's no support in the corner for the wallboard. So I'll have to remind the builder to double check this before I get back. You've got to keep an eye out for the alignment of the studs in each wall. Here's a doorway stud that's bowed out of plane from the rest of the wall. You can check the alignment simply by pressing any straight edge against the wall spanning 4 or 5 studs. This is a typical construction mess, but it all has to go before we can hang drywall. Usually, the electrician will have tucked in these wires, but if he hasn't, I've got to, so they don't interfere with the cutting out of the hole for the electrical box. I usually cut holes for the electrical boxes after the drywall is attached, so I've got to mark their locations now, as well as the position of heat ducts and plumbing cutouts. This mark indicates the exact edge of the heat duct. I also like to mark the location of every stud, wherever we'll be hanging drywall, to make it easier for me to see where to screw into the face of the panels. Now I start measuring the walls and ceilings in each room that gets drywall, so that I can make a list of the lengths and types of panels to order. Here, for example, this wall measures 183.5 inches, which is a few inches over 15 feet. Drywall panels come in even lengths, 8, 10, 12, 14, and 16 feet. So I'll order 2 16-footers for this wall and then cut them to fit. To minimize the total seam length, I'll hang the panels horizontally, right across the window, which I'll cut out later. If I were to hang 8-footers vertically, then I'd have 20 feet of seam to tape, compared to the 11 feet I get with a horizontal layout. Usually the savings is a little less than this, but it's still significant, about 25% of the seam length and the work and taping for going horizontal. I use the wall measurements to tell me what lengths I need for the ceiling. The joist spacing tells me what thickness I'll need in the ceiling panels. And the joist direction also helps me decide what lengths to order, since drywall panels are actually more resistant to sagging along their lengths than across their widths. In the master bedroom, I'm going to measure a ceiling that's about 20 feet long. Drywall panels are not available in lengths over 16 feet, So I've got to figure an arrangement that will minimize the number of butted seams and will keep the butted seams staggered. What's a butted seam, you ask? First of all, here's a tapered edge seam that you will find where the long edges of uncut panels come together. These edges are designed for easy concealment of the finished tape joint. Now here's a butted seam, which you get when joining the ends of panels or any two cut edges. Since these edges have no recess, it's harder to hide the tape seam. This knee wall measures just a little over 54 inches high, so this is an ideal place for 54-inch wide panels. The standard width is 48 inches, but 54s are not hard to get. After I take a few measurements, I enter the size and type of panel on my tally sheet. I use a dot tally system that I learned in forestry school when we were counting trees, but you can use whatever system you like. I'll make a few final tallies and notes, and then I'm ready to place an order to arrive when everything is tidied up and inspected. This house is going to take about 9,500 square feet of drywall. About a week later, my local building supplier delivers a full assortment of links, from 8-footers to 16-footers. I can order these pretty much as I need them, but if you're ordering from a supplier who doesn't normally carry a wide variety of sizes, you better give them a few weeks advance notice. Carrying the panels is usually a two-man job, especially the longer panels. The easiest way that I've found is for both people to be on the same side of the panel, each using the same hand to hold the panel, top and bottom. Let the panel lean in slightly, resting against the shoulder. We're carrying 2 sheets at a time here. When possible, stack the panels on edge against the wall. Segregate the panels by length and thickness and type of drywall, and distribute them around the building. Smaller sheets, certainly 8-footers and 10-footers, you can carry solo. Balance by holding at the center and lean against your shoulder. I've carried 12-footers alone, but I enjoy this work enough so that I don't want to wear myself out while I'm still young. Longer panels are heavier, of course, so I break the bundles apart and we carry them one at a time. If you have to stack the panels on the floor, place them with a good face down so they don't get hurt if they're walked on. And make sure the edges are lined up to avoid damage if it's stepped on. Now, watch Jim and I set this 16-footer down, being careful not to damage the edges or our backs. Now, look at how Jeff and Ira do it. Young bulls. Someday they'll learn. My brother's house has got this convenient balcony over the dining room, so we can easily hand long sheets to the upper story. Without a feature like this, I would have asked the framers to leave us an opening in an exterior wall at the second story level, until we had moved in with the drywall. Now it's a few days later, and we've already started hanging drywall. We always attach ceilings before the walls, so that's what I'm going to show you first. Usually, you'll have simpler framing than in this room, where the ceiling joists are running in 2 directions. We'll account for this change in direction when we position the first panel. But in the normal situation, with all the joists running parallel, you'll just start the first ceiling panel right up against the wall.
154.5.
154.5, which is a 13 feet. And now I'm going to get the measurements so we can place on this ceiling joist here, which is 54.25 inches. Okay, our panel has to splice on this ceiling joist, which is 6.25 inches over 48 inches away from the wall. So I'm going to measure 6.25 inches over here and put a mark there, and then I'll go on the other end and put a mark 6.25 inches. And this will be where we start our first panel, so that it'll splice on the center of that ceiling joist. In order to make it easier to get the panel exactly where we want it, we put a nail and we just butt our sheet to that. Jeff and Ira marked the length of the panel, about 1/4 inch shorter than the actual length they measured at the ceiling, in order to get a slightly loose fit that will protect the edges when the panel is raised. Then they use a 4-foot T-square as a guide for the utility knife. Cut through the paper layer along the square's edge. Snap the panel back away from the cut and then cut the paper face on the other side right in the crease. It doesn't matter which side is scored with the knife first. The guys position the panel by lifting one end into place while they keep the other end low, which keeps the ends from binding as the panel is squared up. Jeff, in the red shirt, is making sure his end is square against the wall, while Ira lifts his end up. Make the spaces between the ends of the panel and the wall even before you start to attach the panel. Jeff and Ira put enough nails into the edge of the panel to tack it in place, so that I can screw the remaining edges and the center. Screws are stronger and less likely to pop loose than nails, so I always use screws across the whole center of the panel. Drywall manufacturers recommend 12-inch spacing between fasteners along each framing member on the ceiling and 16-inch spacing on the wall. The guys are measuring the next panel, which needs a corner cut out to fit around the closet. While the guys cut the next panel, I locate the ceiling electrical box by measuring from 2 known points and writing those measurements close to the point that I measured from. Ira scores the face paper horizontally to begin the cutout for the closet. Then he pencils a line for the saw cut. He has to use a drywall utility saw instead of the knife for this next cut, because he has to go all the way through the panel now, so that he'll be able to cut it completely free with the knife. Meanwhile, Jeff is cutting the panel to length. And once he gets his utility knife back, the guys carry the board in, using a low carry for maneuverability and because the panel should start in a low position for placement. Once again, maneuver the panel into place by starting with one end high and squared to the wall and the other end low. Even up the end spacing.
You good?
This panel covers an electrical box, which we'll need to cut out. So for now, we just tack it into place. There's no real option to a screw gun with a magnetic screw tip for this job. These drywall screws are designed to go into wood. For metal studs, the threads have a finer pitch. Don't mix them up. Get screws long enough to go 5/8 of an inch into wood framing. The gun adjusts so that the screw's head ends up just below the paper surface, without tearing the surface or damaging the gypsum core. I use the measurements on the panel and on the wall to mark the location of the center of the electrical box. Now I use an electric drywall router to cut out around the outside of the box. Push the bit through the drywall at the mark and out until the bit hits the edge of the box. Then withdraw the router, hop over the edge of the box, and cut. Too much pressure against the edge of the box will sometimes break the bit. I always have some extra bits handy. After a quick replacement, I'm back in business. The bit has a pilot end that rides the outside of the box without cutting into it. The proper direction to move is counterclockwise, looking up at the router. For a long, straight cut, Ira holds the tape in his left hand with his forefinger as they stop against the panel edge. He cuts with a knife in the right hand, the blade held against the hook end of the tape. Keep the tape perpendicular to the panel edge. Jeff marks and cuts the length. With the panel on edge, the guys snap away from the scored side and cut in the crease. The end is trimmed off and the narrow strip goes up into place. We use an adjustable step-up bench, also called a trestle, when hanging ceilings 9 feet or lower. Now we hang the steeply pitched ceiling in the bedroom. The ceiling has been furred up to provide solid nailing over the rigid insulation. Since the ceiling is more than 16 feet wide, we'll have to use 2 panels for each row. This means we'll have butted end seams on the ceiling. These seams are staggered as we stack the panels up the ceiling. 135.5. When hanging the pitched ceilings, it's easier to start at the bottom. Once the first row is attached, the other rows are put into place. The bottom edge rests against the lower row of drywall as it's nailed and screwed into place. If these panels were attached from the top down, they'd have to be held up into place, which is more difficult. Yep, good. I've got to place an extra bit of furring here to support the narrow section of drywall that will fill this corner. We always hang the walls after the ceilings. Generally, we hang the first wall panels high on the wall against the ceiling, and the guys are getting ready to do just that. Ira's measuring the height of the window header, while Jeff starts nails along the top of the panel. Ira scribes the header height onto the panel with his utility knife. There are 2 reasons to start the nails before lifting the panel. First, the nails will tell us where the studs are once we have lifted the panel in front of them. Second, starting the nails makes it much easier and faster to drive the nails this way while your other hand is busy holding up the panel. First tack down the top edge, then nail or screw the other edges. Jeff and Ira get the length of the bottom panel, and I use a drywall saw to cut out the window opening. I just guide the saw along the edge of the studs framing the window, sawing until I hit the bottom of the header. Since the back has already been scored, I just snap the panel forward and cut along the crease to free the waste piece. Same sort of thing for the bottom panel. 15 1/4. Measure and scribe to mark the height of the window bottom on the back of the panel. And then start the nails along the top edge. We use a panel lifter to raise the bottom panel up against the top panel. The foot lift works great for any length panels as long as you're going up 1.5 inches or less. It frees both hands for nailing. I've already located the outlet boxes with X's on the floor. So here I am taking off the height to the center of the boxes and marking that above each of the floor marks. Notice that the bottom of the panel has not been fastened yet. This goes just like that ceiling box. But don't apply too much pressure against the panel with the router or with your foot, or the drywall will bust out as the box is cut. That's why you don't fasten the bottom edge before cutting out these boxes. Here's a termite's view of the bit following the outside perimeter of the box. If you don't have a drywall router, you're still in business. With a 2-foot framer square, mark the electrical box edges in height, top and bottom, on the floor. Once the panel is tacked in place, transfer the measurements to the drywall face. Now I carefully follow along the marks with my drywall utility saw. This method is so accurate that I don't even worry about feeling for the box with a saw. If I were to run into the electrical box slightly, I'd simply adjust my aim. Electrical outlet covers won't overlap this opening by much, so you've got to be accurate here. If you're even 1/4 inch off, it'll have to be patched. On sections of walls 4 feet wide or less, I'll often stand the drywall panel on end so that the entire wall is covered by a solid piece. No seams, and no need to cut the panel to width before hanging. I just hang the whole panel and then cut along the outside stud with my utility knife. This time the cutoff won't be wasted. I'll use it later above the closet doorway. When hanging a wall with a doorway, we attach the drywall right across the opening. You don't have to scribe the back because it's accessible. Saw from the finished side of the drywall. You're less likely to tear the face paper this way because the saw cuts on the push stroke and you're pushing into the paper. From the back side, score along the top of the doorway. Snap the section inward and cut it free from the front. Drywall can't be forced into place. If you force a piece that's even a little too wide, it'll bust apart at the edges. Remove the piece and use a drywall rasp to shave the excess width from the edge. That's all it needed, and now the piece fits perfectly. On gabled walls, I like to hang the bottom panels first and work my way up. We start by measuring the height of the little bit of left-hand corner where the next panel will fit. All of our measurements go onto a sketch I made on a scrap of drywall. Same as the last sheet, 14 feet. Because these panels are 4 feet high, I use a 4-foot T-square to find where the top edge will hit against the ceiling. 74.5. The real dimension is 74.5, but I write down 74.25. The 1/4 inch difference will literally get us out of a bind later. We mark the angle with a chalk line and cut with a utility knife. And I smooth out the bumps and rough edges with my drywall rasp. We don't have to pre-start these nails because we're stacking the panels up the wall so we can see where the studs are. Along the ceiling edge, we've pencil marked the stud locations. Somehow we've cut this panel too long. It overlaps the corner nailer for the adjacent wall, but instead of taking it down and remeasuring, I just use the nailer as a cutting guide and trim the edge in place. Another way to treat the intersection of a ceiling and wall is called a floating corner. It's designed to reduce nail pops in the corners due to settling of the framing. We've attached the ceiling panel with screws 7 inches in from the corner. When the wall panel is hung, we keep the top row of screws about 8 inches down, so no fasteners go into the top plate of the wall frame. Use this technique if your building was framed with non-kiln dried lumber or with kiln dried material that's been rained on and never had a chance to dry properly after being framed. The edge of the ceiling panel can't sag because it's held up by the wall panel. After all the drywall is attached, you want to protect all outside angle corners with a metal corner bead. Here I'm installing a full-length corner bead, leaving its bottom end 1/2 inch off the floor. If there's any settling, the bead won't bind and come loose. I drive the nails in pairs on opposite sides of the bead. Make sure the bead's edges lay flat against the wall. Here's a curved wall with a 4-foot radius. I'd call this a moderate curve, but I won't be able to bend 1/2 inch drywall sheets around it. Instead, I'll use 2 plies of 1/4 inch sheets of regular gypsum board, which is much easier to bend. And I made my job even easier by pre-bowing the panels the night before. I just set each end of the stack of panels on a concrete block and let them sag overnight. I'll start on the outside or convex side of the wall. I fasten the edges all the way around as I form the panel around the curve. I cut the panel a little long on purpose. It just needs a quick trim before I push this corner home to a snug fit. I take my time screwing the center of each panel, and I'm careful not to sink the screws in too far into the thin drywall board. After some more trimming, I'm ready for the second layer. Then the first layer on the inside, where the radius is 3 inches tighter. Then the final inside layer. Oops! Well, this happens. At this point, I can try it again, but I didn't want to look too foolish here. So I sent Jeff out for some 1/4 inch flexible drywall, which is half again as costly as a regular 1/4 inch, but it's almost certain to take this curve without trouble. On a concave surface, I fasten at the midpoint of the curve first and work towards the ends. Flex the board slowly and try to press it right up against the underlying curve at the point where the nail will go in. Then nail it. For archways, I hang the face panels right over the opening and cut out along the arch. It's just like any doorway. On the insides of the arches, I attach a double layer of 1/4 inch drywall. First cut the drywall into strips of the proper width. I press these into position slowly and gently, springing between the little ledge made by the top of the vertical strip coming up from the floor and the top of the arch. If I try to do this too quickly, the piece will break. For this 2-foot radius, I nail about 4 inches apart in order to maintain a nice smooth curve. Of course, the curve isn't really smooth yet, but it gets better and better as the flexible corner bead goes on and as the taping progresses until it's a nicely formed arch. On the flat, horizontal, and vertical inside surfaces of the archway, I use regular 1/2 inch thick drywall, which blends in perfectly with the 2 layers of 1/4 inch. You've got to protect the edges of the archway just like any other outside corner. Flexible plastic corner beads are made just for this purpose. They're twice as expensive as metal corners, but they go around a curve more than twice as fast as I could work a metal bead, which I'd have to notch every inch in order to bend it like this. I space the nails roughly 2 inches apart as I form the bead around the arch. I blend it into the metal corner bead by butting the two together, not lapping them. We've just finished hanging all the drywall in this house, and tomorrow we're going to start the first coat of tape and joint compound. So today I'm going to go through and fill in all the larger gaps and damaged areas with a coat of joint compound. I like to fill in any gaps over a 1/4 inch wide. It doesn't take long to check out the whole house. Okay, so we finished attaching all the drywall. Now the next step is to start the taping process. One of the main purposes for taping is to cover all joints and inside corners, any place where the panels have butted into each other has to be covered with taping and joint compounds to strengthen the seam and to help hide the seam. The first coat is called the embedding coat, where the tape is actually embedded in the joint compound. It would be followed, after that dries, be followed by the second coat, which is a filler coat, which widens the seam and helps blend it into the panels. The final coat is just a thin layer that helps blend the panel in together, which is the final goal, is to blend all the seams, inside corners and seams, so we have one smooth surface. I prefer to use a setting type compound for the first coat, which is the tape embedding coat. The compound comes as a dry powder and is mixed with water. I chuck a large paddle mixer into my 1/2-inch drill and stir until smooth. I'm going to let the joint compound set up for a minute, and while I'm waiting for that, I'm going to apply my mesh tape, self-adhesive mesh tape. You just press it into place. And you have to cut it with a knife, or if you had a sharp trowel, that would also cut it. While you're applying the mesh tape, you come across an electrical box. I usually go right across the box with the tape, so that when I'm filling the joint, it avoids some of the joint compound from getting into the box. A minute or so has gone by, so now I'm going to remix the joint compound. And it's a little thinner than I like it, so I'm going to add a little bit more of it, the dry mixture. The consistency should be easy to work with, but not so thin that it will fall off my trowels. Before I apply the compound to the seams, I fill the depressions over the screw heads that fasten the center of the panels. I cover these screws in strips rather than individually because it is faster and easier to sand smooth later on. If a screw still shows after I put a thin coat on it, I always carry a Phillips screwdriver with me, and I just take it and turn that in just a little bit by hand and apply another coat so that it's not showing anymore. Now I'm going to embed the mesh tape in the joint compound. I use a 6-inch taping knife. Apply a even layer of joint compound to the entire seam. Now once that's been applied, I take my 14-inch bevel trowel and I just run it along the seam, along the center of the seam, to smooth out the joint compound. This is the first coat, so it doesn't have to be perfect, but I've kept the edges beveled and a nice smooth surface. And then I get the other little seams here with a coat of joint compound. I'm going to apply the joint compound to the inside corner. It's a thin layer. I apply it to both edges. The important thing to remember here is to keep it smooth, but it can't be so thin that you can see through the joint compound and see the drywall surface. It has to be, drywall surface has to be completely covered with joint compound. And all cracks have to be filled. On all inside corners I use the pre-creased paper tape. It already has a slight crease in it, and I just pull it between my fingers as I'm pulling it off the tape holder. Stick it up into the upper part of the corner and press it into place. I don't press it in the entire length, I just press it in like every 18 inches or so. When you get to the bottom, I just tear it off with my hands and push it into place. But as I was pushing it into place, I was pulling it tight, so it's not a lot of wrinkles, it's not really loose. Okay, now I'll take my 6-inch taping knife and press the paper into the joint compound. Putting quite a bit of pressure on it, cleaning up the joint compound so that I don't have an excess amount still along the edge. I try to keep it as smooth as possible. If any wrinkles do appear, I'll just go over it again and press the wrinkle out. And before I leave this corner, I want to straighten out any excessive trowel marks that I've left. And I just go over it lightly with the knife and clean it up a little. Now I'm going to put a coat of joint compound on the metal outside corner. If there's a seam intersecting with that corner, I'm going to put the first coat on both things at the same time. I'm just using my 6-inch knife and going 4 or 5 inches wide with a consistent layer of joint compound. Now I just smooth it out. This is the first coat, and it doesn't have to be real smooth. The most important thing to remember here is to keep the corner bead, the very outside edge, clean. I don't have a real heavy buildup, I don't have any buildup at all really on that edge. You can still see the very edge of the corner bead. And I just touch it up a little bit. Here's an example of a metal outside corner that doesn't have a intersecting seam, and you'll see that's a little easier to apply the first coat to. I just take my 14-inch trowel and go right along the edge of the corner. And I have a lot of excess that's on that very outside edge. Now I'll just take my knife and clean that off. I prefer to use the mesh tape when taping these seams because it's faster and it's pretty much foolproof. But another way to do it is to use a paper tape, which is quite popular and perfectly acceptable. But in order to embed the paper tape, you have to apply the joint compound to the seam first. A nice thin, even layer with no dry areas. So you just roll the paper tape out and try to center it on the seam. If you look closely, you can see through the compound and see the slight indication of where the seam actually is. Notice how I'm not pushing it right into place. I'm keeping it pulled tight and I'm pressing it in like every 2 or 3 feet. Okay, once the tape has been stuck in place, I embed it by using my 6-inch trowel. I roll it down, run it down each edge, cleaning off the excess joint compound, and pushing the tape into the compound. It should be pretty much wrinkle-free, and the edges should be tapered. You'll seldom be able to reach ceilings from the ground, so a plank attached to empty joint compound rails works for me as a homemade scaffold, at least for 8-foot ceilings. I still want to tape as long a seam as possible in one go. I cover the seams and inside corners that are within reach before I move the scaffolding to the next area. This edge works great, but it's kind of slow and cumbersome. I'd much rather use stilts for these lower ceilings. On house-size jobs, drywall or stilts are a great productivity tool, and it doesn't take too long to get the hang of them. But check to see if they're legal in your state and if your insurance covers their use. Okay, I'm going to be starting the second coat on the ceilings first, using my 14-inch bevel trowel and the 6-inch taping knife. Whenever I start taping, I'm going to put a little bit of joint compound on the trowel and then put the second coat on the screws first. Taking most of the joint compound off, just leaving a very thin layer. All I'm trying to do here is fill the indentation caused by the fastener. I'm not trying to build up the joint compound anyplace else. The reason I'm doing the fasteners before I do the actual seams is because when I get taping this seam, if this seam has already been taped, and then when I go to do the fasteners, I could interfere with this tape joint with the taping knife. So I'm trying to avoid any potential marks in my seams. Now, I'm going to start after I get the fastener done, I'll do the interior corners. Okay, when I'm applying the joint compound with my taping knife, all I'm trying to do is get it fairly even. When I go to take the joint compound off, or to smooth it, is when I'm holding the trowel at an angle. If I hold it straight up like this, it's very hard to leave a little bit on. Most of it will come off. So when I'm smoothing it, I hold the trowel at quite an angle. Not flat against it, but enough of an angle to not take all the joint compound. And I'm putting quite a bit of pressure on it. You can see the trowel bending even a little as I remove the joint compound. It's not just letting the trowel do it. I'm putting quite a bit of weight into it. When I'm actually doing the smoothing, I'm taking very little off. I ran that knife 6 feet and I've only taken off a very little bit of joint compound. All I'm really doing is smoothing out what's there now. If there's a little bit of, a few chunks of dry joint compound in the corners, I just take my 6-inch knife and scrape them off before I apply the joint compound. And keep in mind as you're doing this that this is a second coat. It's not the final coat. It's not going to be perfect. I could spend an hour on this corner and it would still never be perfect. So you got to walk away from it after a while. You can see that there are some slight wrinkles in the tape here. And that's what we're trying to get covered on the second coat. Making sure that those wrinkles no longer show after the second coat of joint compound and smooth it out. I've already taped the fasteners and second coated all the inside corners, and now I'm going to apply the second coat to the seams. I use my 6-inch taping knife to apply a thin coat to each side of the seam. Probably about 4 inches to each side of the seam, 4 or 5 inches wide. And get it as even as possible, about probably a 1/4 inch thick or a little less than a 1/4 inch thick. And keep it straight. And then this is when I use my 14-inch bevel trowel to smooth the joint compound. First, I'll do one edge at a time, smoothing the edge out. All the pressure on this trowel is on the outside edge, trying to get that as smooth as possible. I took off quite a bit of joint compound. Now I'll go over to the other edge and get that as smooth as possible, keeping all the pressure on the outside edge. My producer was a little confused about what I meant by a beveled trowel, so I'll show you what I mean. Maybe I should call this a curved trowel because it's cambered or curved along its length so that the center of the trowel lays down roughly an 1/8 inch thickness of compound, while the edges feather out the compound to almost no thickness at all. Now I'll take the trowel and apply an even pressure to both edges, which will smooth the center of the seam. The edges are still beveled pretty well, and the center is getting smoother. There's quite a few air bubbles, so I'll have to go over it 2 or 3 more times before I'm satisfied with it. Checking to make sure the edges are still beveled. You're not going to get all the air bubbles out, but right now I've got just very few small ones, and that's fine for your second coat. After the second coat of compound is dry and before I apply the third coat, I like to sand out any trowel marks or ridges or unfeathered edges that I left while second coating. I call this light sanding, and it only takes a few minutes to do each room. This light sanding makes it easier for me to apply a smooth, thin third coat of compound. I am careful not to oversand. I don't want to expose the tape or hollow out a length of seam. Some tapers skip this step, but I think it saves time by making for an easier application of the third coat and an easier final sanding. You don't want to breathe this stuff, so you've got to wear a dust mask. When you're shopping for these, read the labels and make sure the manufacturer says they're good against non-toxic fine dust. For the third coat, I always use ready mix compound. Unlike the powdered setting types, this stuff can be thinned down with water anytime after I've opened the bucket, and it doesn't dry out as quickly while I'm using it. These are handy characteristics for the third coat because I trowel it on so thin and then I trowel almost all of it right back off again. This much working would quickly harden a setting compound which can't be rethinned. Also, the ready mix compound is softer and easier to sand than setting compound once it dries, but you still have to stir the ready mix to even it out. Just as in the previous coats, I tape the fasteners first, still applying just a thin coat. One method for applying the joint compound on the seams for the final coat is with a 12-inch straight-handled trowel. Just take the joint compound and apply it to the seam. I'm going wider than the seam by 1 or 2 inches, as long as you go wider. The idea behind the finished coat is to keep everything nice and beveled and finished smooth. So once I get a nice thin layer on there, I take the same 12-inch trowel and I remove most of the joint compound. What I just did there was feather that edge in. Now I'm going to feather the bottom edge in, removing most of the joint compound. Now all I have left to do now is to clean off the center. I've removed most of the joint compound. The only joint compound left is what's filling in any ridges I had before. I notice there is a little ridge right here. And things like that I'm looking for as I'm applying the third coat. So I'll just put a little more joint compound on my trowel And I know that needs to be filled a little bit more. So I'll just leave it on a little heavier. Most of it's still off. There's another little ridge here that I can see. And I just lightly go over that, leaving on a little more joint compound. And that's a good smooth third coat on the seam. It's the same idea when I'm third coating the inside corner. I'm putting on a layer of joint compound. Well, this time I'm still using my 6-inch taping knife. And then I'll taper the edge in, clean that right off. Both edges I like to do. So now my edges are nice and feathered out, wider than they were before. And I'm just going to clean the inside up, taking almost all the joint compound out. Now I do damage the other side a little bit when I finish both sides. And I just go over it by putting a little bit more joint compound in. Now I add some water to the joint compound to thin it down a little. I like to have a thinner mix before third coating the ceiling because I can move more quickly with a paint roller. But don't thin the compound too much. 2 or 3 cups per 5-gallon pail is plenty. The compound has to be thick enough to stay in place when applied. It shouldn't drip off the ceiling. I just roll the compound on the seam, widening it out a little, applying a thin, fairly even layer. Usually, the entire length of a seam can be done at once. Now I remove the compound in the same manner as before. Seams on 8-foot ceilings can usually be troweled from the floor. You can get trowels with longer handles if you need them, or use benches or silts to reach the ceiling. Once the third coat is dry, I'm ready to start the finish sanding. I always use a good quality dust mask. I start the sanding with a pole sander using a 120 grit or finer sanding screen or paper. I've got a good 300-watt light shining tangent to the area I'm sanding, so that any slight ridge throws a shadow that I'll easily see. These screens are made of fiberglass and coated with a carbide grit, both sides. They don't fly the way sandpaper might. This is a switch box I'm sanding over. This is obviously the dustiest part of the job. Joint compound manufacturers seem to think that sanding is avoidable, but I know that a high-quality finish will require some sanding. Wet sanding would produce no dust at all, but it's slow and it doesn't get me the results I'm looking for. If you hate the electrician, don't bother to clean out these electrical boxes. But if you want to keep him as a friend, this is the time to cut through the tape with a taping knife and mug out the boxes. I'll vacuum them out later. Now I'm ready for the final touch-up sanding. I use hand sanding tools as I look and feel for any defects that I couldn't get out with a pole sander. This hand sander uses the same screens I use with my sanding pole. A dry sanding sponge and a folded piece of sanding screen help me smooth out hard to get at areas like the very inside crease of this corner. The pole sander works great on ceilings. I've got excellent leverage and everything's within reach. No drywalling job can be called complete until the mess is cleaned up. I use an old knife to scrape compound off the floors. I vacuum out electrical boxes, heating ducts, and clean up around window openings. I think the room looks just great like this, but most people prefer to paint. Unfortunately, drywall is rather susceptible to damage, especially while a building is under construction. Fortunately though, it's easy to repair. This is just a scrape, but the paper's been torn. I first remove any loose paper and then I cover the area with a layer of mesh tape and joint compound. I feather the area out with 2 or 3 coats of compound, avoiding a bump that might show after painting. Sometimes you know that even the most careful worker is going to run into trouble. First I cut a patch out of a scrap piece of drywall, a little larger than the damaged area. Then I hold it over the hole and trace around the edges. I trim to the outline with my utility saw, cutting out the damaged area. I need something to attach the drywall patch to. I cut 2 pieces of furring about 4 inches longer than the hole and screw through the panel into the furring, which will hold it firmly in place. The patch goes into the opening and is screwed to the furring. The patch is now a rigid, flush part of the panel surface. I fill in the gaps with joint compound before applying the mesh tape. I feather the joint compound in around the patch. A patch this large requires 3 coats of joint compound. Sometimes your client will change his mind about the location of a window or a door or a closet opening. Large openings need to be framed in so that there's plenty of nailing surfaces to attach the drywall to. Whenever possible, fill in the area with a single piece of drywall. It's bad enough that all 4 edges of this patch are butted seams. I wouldn't want an additional seam to contend with. It usually takes me 4 coats of joint compound to conceal a patch like this. I hope I've shown you that although drywalling is no simple process, it is nothing that you should be afraid of trying your hand at. As in most building trades, the right tools and materials are important, and proper planning is essential for a first-rate job. But a can-do attitude is most important to help get you through the rough spots as you're learning. Thanks for watching, and read my book,